Alright guys, welcome back. Today we're going to start talking about how we can convert Cartesian equations into spherical equations and vice versa. And so I'm going to just say that we're going to start using these equations that you see right here. And let's go ahead and begin. So the first question says we are given a Cartesian equation of x squared plus y squared plus z squared minus 2z is equal to 0. And so first thing we're going to realize here is that if I remember, rho is actually equal to the square root of x squared plus y squared plus z squared. So actually, if I were to do rho squared, I actually get back the thing I just underlined here. So I can actually replace all of this with simply rho squared. And so now I have rho squared minus 2z. We now know that z is actually equal to rho cosine of phi. And so I can go ahead and replace z with this equation, and we are now officially done with this particular problem. There really isn't anything else I can do with it. So we're now going to shift gears, and we're going to look at the more challenging problems, I would have to say here, is how to go from spherical equations back to Cartesian equations. So some of these times we look at these problems and we're like, okay, well, we got to kind of figure out how we can manipulate this a little bit. So we see that we have sine of phi and then cosine of theta. And so we're thinking, okay, well, what equation has a sine of phi, cosine of theta? And so, okay, well, we know that x actually is equal to rho sine of phi cosine theta. So what we can do here is we can actually divide by rho in our manipulation of this, and so we're given back this right here. So I can replace the sine of phi cosine of theta actually with 2 times x over rho, and then we can cross multiply. I get rho squared equals 2 times x, and we now know what rho is. So just like we said in the previous example up here, right? Rho is simply, or rho squared is going to be equal to x squared plus y squared plus z squared, and we get that this is equal to 2x. And then the only thing else that I could absolutely do if I wanted to set it equal to 0 is just move the 2x over, and we are good with this particular problem. So there is our solution to this one problem. So that being said, what I encourage you guys to do now is looking at the equations that we know. I'm going to say maybe pause the video and see if you guys can take this equation right here and see if you can manipulate it to Cartesian, and we're going to come back and we're going to talk about it together. So take a moment and we'll go over the question with you guys. Okay, so here's the first thing we're going to do here. So I have a cosecant here. There was no cosecant in any of our equations, so I'm going to divide both sides by cosecant, and so I'll have rho, and then I have sine of phi is equal to 2. All right, so I'm trying to manipulate these equations to something that we can actually use some substitution for. So one thing that I can also now do is square everything. All right, and so I've got my rho squared and then my sine squared of my phi, and then I'm going to go ahead and rewrite sine squared as 1 minus cosine squared phi. And so I use the identity of sine squared plus cosine squared gives you your 1. And then I'm going to go ahead and from here I need to distribute. And you're probably thinking, you know, why did I do this? Why did I go and do sine over here? I didn't want to go ahead and multiply both sides by something with a cosine or sine because I don't know what to do with the 4 over here. So I can manipulate this problem with this particular example that I now know that rho, we've said many times now, squared is going to be x squared plus y squared plus z squared. But more importantly, if you guys look at this, we now know that p squared cosine squared of phi is actually going to be z squared, right? Because z is actually equal to rho cosine of phi. So I now have the fact that this ends up being z squared. And so I can obviously cancel out my z squareds. And so I'm left with x squared plus y squared is equal to 4. And now we're finally good with that problem. So this problem was a little bit more challenging for us to do because it may not be pretty obvious what to do with this problem. But this is a good indication of what we need to do. But we're trying to manipulate these problems to find the equations that we need to substitute in. All right, we're going to do one more example here together, and here it is. We want to change the equation of r squared equals x squared plus y squared, and we want an equation now with rho in it. So the first thing that I'm going to do here is I'm going to go ahead and change my x and my y into the equations that I know that they are. So I know that x is actually going to be equal to rho. I'm going to go ahead and square that. It's also going to be sine of phi, and then be cosine of theta. And I need to make sure that I square each of my little parts here. And then I'm going to go ahead and do y, same thing with everything else. It's rho squared, it's going to be sine squared of phi, and then cosine squared of theta. Oops, wrong. I just was looking at the x one again. I'm going to say that this is actually the sine, right? So there we go. And just like before, it's really common for us to let's see what we have in common here. So we have the fact that rho squared are both. We also have the fact that sine squared of phi is also in both of them. And so if I were to distribute that particular two terms here, I get, that's supposed to be a theta. That does not look like theta, so let's go ahead and fix that for us. And then I get this nice, beautiful identity that we all love in the world of trig, right? We know this is 1. So I'll get that r squared is equal to, in this case here again, rho squared, sine squared of phi. And then what I can now do is just take the square root of everything and finish our answer that r is actually going to be equal to rho times the sine of phi. And there we go with our particular example for this right here. And so that is our examples now for our equations. So again, the thing that you want to start doing, and I'm going to go back to the equations up here, is that you want to remember these equations pretty well. And so if you're trying to find stuff in terms of x, in terms of y, see if you can manipulate this to where you get this, right? And this is the idea that we're trying to do with these problems. So I hope these are helpful, and I will see you guys in the next video.